We're talking about three basic methods of charging bodies. Three basic methods of charging bodies. Three basic methods. Well, the first one to consider is charging by contacts. Charging by contacts, bracket or conduction. Conduction. Then after that, we consider charging by friction. Then lastly, we have charging by induction. Let's start with the very first one, charging by contacts. Charging by contacts. Well, charging by contact is no other thing than bringing a body to be charged. That is a body of unknown polarity, a body that has not been charged before. Close and indirect rapport, that is indirect contact with an already charged body. I will give like I said, charging by contact, charging by contacts, or what you call conduction. Now, let's say this is a body, this body is charged. That is body A. Let's say you are positively charged. Now, let me put it under an insulator. This is an insulator. Now, and this is a body to be charged, body B. Body B is a body of an unknown polarity. It doesn't have any charge yet. So unknown polarity is, so I put it under an insulator. Now, during this is before charging. This thing, all this one now is before charging. Before charging. Now, during charging, you see that if this is to be an insulator body now, you see body A and body A and B are in direct contact, they are positively charged. Why this is body A, this is body B. This is during charging. This one is during charging. Then you see after charging now, you will have your body A, and you have your body B. This is positively charged, and this end up acquiring a positive charge. That is what you need to know under charging by contact. It requires direct rapport, direct touching of a body to be charged to an already charged body. Charged body, like you see body A here, body A is a charged body, that is body of known polarity. Body known polarity. Body B is an uncharged body, that is body of unknown polarity. So that's what happened during charging by contact. This is it. You see that the body to be charged end up acquiring the same type of charge with that of the charged body. So the body to be charged end up acquiring the same type of charge with that of the what? Charged body. So that is it. If you want to charge a body positively by contact, you must use a positively charged body. If you want to charge a body negatively by contact, you must use a negatively charged body like this. This is body A now, and this is body B. So when they touch each other, put them under insulator to separate them from the charges of the earth. Then when you bring them in contact, you see, charging by contact, these are the basic things that you need to know. You use it to charge mostly conductors, things that can allow easy flow of electrons. this is what you have when you charge a body by contact, whether you use positive charge or negative charge. Now let's go. Charging by, we're done with contacts. Let's talk about charging by friction. Frictional method of charging by. Well, friction is the only method of charging insulators. It is the only method of charging insulators. And this requires bringing two neutral bodies or uncharged bodies. Yes, it can be insulators, it can be conductors. So bringing them and rubbing them vigorously on each other, rubbing them vigorously on each other. And you see, at the end of the charging process, the two neutral bodies end up acquiring an opposite type of charge. That is what happens under charging by friction. Now let's say for frictional method now, frictional method. Now friction is a force that opposes motion between two objects in contact. Force that opposes motion between two objects in contact. So let's say this is A, which is neutral body A, and this B, and that's another neutral body B. Neutral body in the sense that none of them have a given polarity. So what you need to do here is that when you bring them, you rub them vigorously on each other. You rub them, that's why in our secondary school you do plastic rod, ebonite, and fork. You do this. When you generate the force, you bring it towards a tiny piece of paper and it will attract. So that is what friction is all about. That means bringing two uncharged bodies and rubbing them vigorously on each other. So at the end of the charging process, that is at the end of the rubbing, when you bring body close to a tiny piece of paper, it will be what? Attracted. Like when you rub your ebonite, plastic rod, the biro, the bottom of the biro or beak. After a while, bring it towards a tiny piece of paper and it will pick it up immediately. That's charging by friction. So you see here, to show you there is rubbing, you must rub the two piston bodies. I'm going to have something like this to show that they are touching each other. So that is it. So let's say this is body A and this is body B, or body B, whichever one. So you show that you are rubbing them, they are touching each other. Then at the end of the rub, you see that body A, if body A acquired positive charge, body B will acquire negative charge. Example of this, we talk about ebonite rods, ebonite rod, or what you call plastic rod plus what? 4. That is charging by friction. You see, at the end of the charging process, ebonite become negatively charged, as 4 become positively charged. What happened? 4 is positively charged because it transfer electron. It lose electron to ebonite, and ebonite acquire electron to become negatively charged. Another example is when you have grass, that is number 1. Number 2, when you have grass rod plus silk. Now, grass rod is positively charged because you use electron to silk, which end up becoming negatively charged. So these are what we consider under charging by friction. You must know this polarity. Don't misplace the sign, because you go, there are some ebonite rod that have been charged in combination with grass rod that have been charged. You see, attraction will take place when you combine these two things. There will be what? Attraction. There will be an attraction. The same thing when you combine silk and charged silk with charged 4. You see, there will also be what? Attraction. Attraction will also take place in the attraction. But when you combine ebonite rod and silk, that is charged ebonite with charged silk, these two will show repulsion. The same thing with 4 and grass rod, there will be what? Repulsion again. Repulsion. So these are the important things that you'll be expecting from any exam. Remember, we still have polythene plus. Alright, like I said, we still have other examples of charging by friction, as like ebonite plus 4, grass rod plus silk. We have polythene and woolen cloth, of which polythene become negatively charged as Wooden could become what? Positively charged. And we have lastly cellulose acetates and cotton crows. Here, cellulose end up losing electron, making it positively charged, as cotton crows accepts the electron, making it what? Negatively charged. Then we go to the last version of this series, which we call charging by induction. Induction, electrostatic induction. Induction. Now take a look at this. Now induction, charging by induction. Induction, charging by induction. This, of course, no, this require bringing a body close, but not in contact. Bringing, it requires bringing a body to be charged close, but not in contact to the charged body. Charged body. So you bring it close but not in contact with the charged body. There, for instance, we have an ebonite. Let's say we have an ebonite rod. Yes, let me separate it. This is an ebonite. Ebonite is known to be negatively charged. And we have a body to be charged. A body, this is body to be charged. And let me also put it under an insulator base. This is a neutral body. This A is an ebonite. That is an ebonite. Ebonite rod. And this is a neutral body B. B is what? Neutral body. Neutral body B. So that is a neutral body B. So we want to charge this by induction. Simply means bringing this body close but not in contact. Look at this. You bring it close. This is your ebonite. This is your ebonite. And you bring a body close. Ebonite, let me put it under a base, an insulator base. So you bring it close but not in contact. You see? So close but not in contact. So when you do that, this is an insulator base anyway. This is an insulator. You bring it close. This is body A, charged body, this body B. Now the first thing that will take place here, a neutral body is a body that have equal amount of both positive and negative charge, so they counterbalance each other. So with that, it is said to have no charge. So you see, a neutral body, this body must charge this same body with exactly the amount of the charge, the amount or the magnitude of charge that you have, but it will be the opposite type of charge. Induction, what will happen here is that first thing is there will be a polarization of charge. What do I mean by that? Charge separation. So what will happen is, look at this body A, which is negatively charged. This is body B. Let me see, put it under a base. Now this body B, that is an insulator base. Having an insulator, a neutral body with an insulator base. Now, what will happen is that this charge, being negative, will draw the equal amount of the positive charge in this body closer to itself, while the other negative will go to the opposite side. You see it now. This is during charge. This is happening during charge. This is what happened. Then you have this. Then it is required that during charging you connect an earth wire. The essence of earthing is to transfer excess electron down to the earth. You transfer excess electron that can easily bring commotion or cause burning down to the earth. So during charging, you connect an earth wire. The essence of earthing, this electron will flow the earthing and flow down. That is during charging. This is happening during charging. During charging. Then after charging, you seal the body, the body, then you cut your earth wire. Why do you cut earth wire after charging? You cut your earth wire, this body. Alright, like I said, after charging, you cut off the earth wire. And why do you do that? To avoid backflow of electron. Backflow of electron. Those electrons that you transfer here, move down to the earth. You can see electron move down to the earth. That's what we call grounding or earthing. That is the essence of connecting earth wire. This electron here, because you want to charge this body positively by that is the reason why you bring a negatively charged ebonite rod and all that. So with that, the electron will flow down, leaving the net positive charge on this. But that is why we call the earth wire here. As after charge, disconnect the earth wire to avoid backflow of what? Electrons. And you see, since it's a conductor is known for easy flow of electron. So electron can now take time to distribute evenly. That is one of the difference between charging a conductor and insulator. If it's an insulator, those charge will remain at the point of contact. But if it is a conductor, it will just take little time to distribute what evenly to other part of the body of the conductor. So what do I want you to understand here? I want you to understand that charging by contacts required close rapport, that the two bodies will be touching each other. Not only that, at the end of the charging process, the body to be charged end up acquiring the same type of charge. That is what you need to know about contact. You end up acquiring the same type of charge. What about charging? But that is one of the special thing about contact. Our acquire. That is if you press your hand on a hot object, you feel hot. You press it on a cold object, the same thing. That is just it. So that is what contact is all about. Then we talk about charging by friction. This one also require contact, though it's not just contacts. It requires contacts and rubbing the body what vigorously on each other. You are rubbing it. That is where friction. Friction is a force that opposes motion between two objects in contact. You see it now. It is a special type of contact. And that is why I say it is the only method of charging insulators. You can see I mentioned ebonite rod and 4, whereby ebonite becomes negatively charged for accepting electron from the 4 and 4 positively charged. I mentioned glass rod and silk. And you see, glass rod become positively charged for giving electron to silk, which end up becoming negatively charged. We talk about cellulose, acetate, and cotton cloth. Cellulose is positively charged, cotton cloth is negatively charged. We talk about polythene and woolen cloth. You see, polythene is negatively charged for accepting electron from the woolen cloth, which end up becoming positively charged. So you see, charging by electrostatic induction. Induction requires close but not in contact. You see, friction and contact is direct rapport. They will be touching, but induction requires bring it close but not in contact to the charged body. At the end of the charging process, you see that the body to be charged end up acquiring an opposite type of charge. Please don't forget this is very, very, very important. They end up acquiring an opposite type of, and it is only induction require earthing measuring. I've told you the reason of earthing is to transfer excessive electron down to the earth that can easily cause explosion or something like that. That's why at times you see petroleum tanker when you want to empty its contents. Yes, you see they put a metallic chain that will conduct excess charges that accumulate while traveling through the air and while moving around and all that. The those things, those static cranes, those things that can easily cause explosion, they put down metallic chain to conduct those charges down to the earth. The same thing, airplane as it's flying through the air, you see it's acquiring and accumulating charges. And the tire is made in such a way that as soon as it lands on the ground, running on the ground will now conduct those charges away. The same thing, you go to hospital, the hospital or patient beds, also those charges accumulated. It is the tire of those those roll on those hospital bed, the tire, you see, also have a material that conduct away these charges. The shoe, the attire of medical doctors also have a way that it conducts these excess charges down to the earth. All these are application of electrostatic induction anywhere. But I want you to understand induction requires close but not in contact. All right. So let's consider some questions in this topic. We have a question before us on the board, and they are asking, look at the question. I give the diagram whereby this is a positive, can be positively charged grass rod, it can be grass rod, it can be four. Now, it can be anything, but it's a positively charged, this body. Then these things are two uncharged body on an insulating stand. Let's say X and Y are uncharged conductors in contact and on insulating stands. A positively charged rod is then brought close to X and Y, as shown in the diagram above. If X and Y are separated while the rod is held near them, what happened? What happened? This one said A, both X and Y will be negatively charged. B, both X and Y will be positively charged. C, X will be negatively charged and Y will be what? Positively charged. And D, X will be negatively charged and Y uncharged. E, X will be positively charged and Y uncharged. Now look at this. Solution. You see, this is a body. We are positively charged, and we bring two conductors on insulating stand, but they are in contact with each other. So these are the conductors on the insulating stand. First thing that will happen, this conductor will draw all the input conductors, all the opposite type of charge, the positive, the negative charge to this side, the equal magnitude of the charge that I have, or the opposite one. As the negative to withdraw it, while repairing all the positive charge to the no light charge, repair while unlike charge attract. So this is it. Remember, this is your X, this is your Y. So when you separate these conductors, when you separate them now, this is what you are going to have. You have that body which is positively charged. Then you have the first conductor. We have the first conductor X to be negatively charged. That is it. You have the second conductor Y to be positively charged. So that is why the correct answer is that it's option C. Correct. Option is C. X will be negatively charged and Y will be positively charged. That's what you need to know. There are plenty things, questions to consider under this. Now we have a question. Again. A question said, in the process of electrification by induction, the amount of induced charge in relation to the inducing charge is the A, same in sign and quantity, B, same in sign but greater, C, opposite in sign but greater, D, opposite in sign but less. And then option E says opposite in sign and equal. In the process of electrification by induction, the amount of induced charge in relation to the inducing charge is dashed. So you see, if you talk about induction, let me just use this. You see, this is the one that is inducing. This is the one. You see, this is the charge. You want to use and charge this electrostatically by induction. So how many quantity of charge are here? 4. And the same, it is going to be what you will induce. Let me just use a particular listing. This one is a special case. Oh, I just created this thing. Now, let's say this is it. You are positively charged and this is your steady. So what will happen here, if you are charging by induction, you see, you will induce equal amounts of the charge that you have, or opposite in nature. You see it now. So then, why the other one? Okay, let me use negatively charged. For that, this is it, negatively charged. So the charge that you induce will be equal. This is an insulator base, we also an insulator base. You induce this. They are equal but opposite in sign. Then why the other one? Then you connect earth wire to transfer this electron to the earth. Then after earthing, you cut it off. You see the Alright, you can see that body end up becoming positively charged after you got your earth wire and all that. So these are the kind of questions you should be expecting on this aspect before I proceed. And look at another question. What is the, okay, this question, what is the correct sequence? All right, the question says, what is the correct sequence of steps for charging an insulated conductor by induction? I, bringing a charged body near to the conductor, I removing the charged body, I touching the conductor with a finger, and this removing the finger. So these are the various steps listed. Then we have to arrange it according to which one comes first before the other, and like that till the last step. Now you see option A, you see the various options IV, IV, and I. I, Ivy, Ivy, I, and and Ivy. So which of them is correct? So I want you to understand something. The first step, let's look at this. You must bring a body that you want to charge. Bring in a charged body near to the conductor. You want to charge conductor, so bring a body that is charged. Cruise. So this one, we're reasoning it to be the number one. Then after that, I say removing the charged body. No. Before you remove the charged body, something else must be done. Touching the conductor with a finger. Yes. This is after this. This is the next step. Touching a conductor with finger. We call this earthing. We call it earthing. Then after earthing, you see, you must remove the cut the earth wire by removing your finger. Now, our body is a perfect conductor, can also move electron through us down to the earth. So you touch it with the finger, and with that you have removed excessive electron. Then here, this you cut. This means simply cutting the earth wire, cutting the removing your finger from the conductor, meaning you have stopped the flow of electron, cutting the earth wire. So that is it. And when you cut it, the last this thing I'm going to consider is then remove the charge body because you are not charging. So the answer is going to be what? Option B is correct, which says I, then IV, and lastly I. So this is the correct steps towards being that. That's the correct step. One more question. All right, to conclude this, look at this question. This question says, an ebonite rod rubbed with fur attracts a grass rod rubbed with silk. All right, like I said, let's consider this question. An ebonite rod rubbed with fur attracts a grass rod rubbed with silk because ebonite has a negative charge while grass has a positive charge. B, ebonite has a positive charge while grass has a negative charge. C, both have negative charge. And D, both has positive charge. Of course, the correct answer, we are going to determine that with this solution. You know, when you said ebonite, or what you call plastic rod, I've given this before, plus 4. You are negatively charged at the end of the process, while you are positively charged. So we have grass rods plus silk. You are positively charged while you are negatively charged. So the attraction that happen here, because they attract grass rod with silk, yes, attraction, because according to fundamental law of charges, light charge repel while unlike charge attracts. So attraction will take place because of their what? Different polarity of charges. So all these are just the question. I'll do more of this with respect to time, but use this and balance up your knowledge on electrostatics. Yes, use this to help you very well. Every exam will involve around big Joe